So we have this idea of these valence electrons existing in orbitals. And we've already talked about electron configuration, and we could say something like, oh, well, those electrons are in the 2s orbital or the 2p orbital or something like that. And that gives us kind of a spatial awareness of where those electrons are. But when it comes to actually getting an idea of how these bonds are forming, that creates or presents a little bit more of a challenge. So there's an effort to try to explain that. And so as an example, let's use carbon and hydrogen combining to make the molecule methane. Methane has a simple formula of CH4. So carbon rolls in with 4 valence electrons. Now, those 4 valence electrons are in 2s2 and 2p2. Okay, so we've got those 4 valence electrons. Then we've got a total of 4 hydrogens. Each one of those hydrogens has an electron in the 1s orbital. Okay, so how are we going to kind of reconcile these differences, the different placement of these electrons? Ultimately, this is the molecule that we come up with, CH4, 4 hydrogens surrounding 1 central carbon. But in order to give an explanation for how an electron in a spherically shaped s orbital pairs up with an electron in a p orbital, a dumbbell shaped orbital, well, we came up with, or there was an explanation known as hybridization. So if we look at the electron configuration for our carbon, we've got 1s2, 2s2, 2p2, okay? So our unpaired electrons there are going to be in that p orbital. How many unpaired electrons do we actually have? We've got 2 of them, okay? How do we know that there are 4 bonds? But we know there are 4 bonds, so what are we actually going to do? What we're going to do with that information is we are going to hybridize those orbitals. And here's a picture of a hybrid vehicle, gas electric, or actually I think that's just an electric car, but nevertheless, we're going to hybridize those orbitals. So what we're going to do is we're going to take our valence electrons for carbon, the 2 electrons in the 2s orbital and the 2 electrons in the 2p orbital. And we're going to elevate one of these electrons into a p orbital. Okay, so what we've done is we've just moved this electron right here, there. So now we've got an electron that we basically bumped up from a 2s orbital to a 2p orbital. And so what does that give us? That gives us 4 unpaired electrons. So basically that gives us the opportunity for each one of hydrogen's electrons to roll in and say, oh, perfect, that's exactly where I need to throw my electron. Now we've got a bond, awesome. So what we've got is our s orbital and our p orbital. But it seems like, or what we know to be true is that s orbital electrons like to pair with s orbital electrons. And so there's this concept known as hybridization. So rather than it being 4 unpaired electrons in an s orbital and 3 p orbitals, instead we combine these orbitals. So this right here, which was an s orbital, and this is a p, a p, a p, a spherically shaped orbital, a dumbbell, there's my dumbbell, a dumbbell, and a dumbbell. Well, now, all of a sudden, we have an orbital that is this, plus this, plus this, that it looks a little bit more like this. Where we have 3 one s orbital and 3 p orbitals. This is known as an sp3 orbital. So it has 25% s appearance and 75% p appearance. So what that means is that we've hybridized the electrons in that carbon, or the orbitals in which they are, to make an sp3 hybrid orbital. That means that each one of those hydrogens that has an electron in a s orbital says, oh, well, this orbital at least looks something similar to the orbital that I was trying to get into. Okay, so that allows that bonding to take place. Now, ultimately what that means is this is the way that basically bonds are formed, where you have these orbitals that are distinct from one another, that they are merged with other orbitals to make a hybrid orbital. Okay, so what that orbital looks like is depicted here. So this right here is an s orbital. This is a p, this is a p, this is a p. So all of these, 1, 2, 3 orbitals, 4 orbitals, I'm sorry, they get added together and they produce orbitals that look like all of these right here. So think about this as an average of all of these things. Think about this one as an average of, well, all of these. So this right here, I've just drawn an X, that's where our central carbon is. Then we have an electron in an orbital that is partially S and 3 parts P. It's an sp3 hybrid orbital. Okay, so that's the kind of foundational concept between or of orbital hybridization. So what we have with that, in addition to sp3 hybridization, is we could also hybridize an orbital or hybridize orbitals that are 2 p orbitals and 1 s orbital. That would make an sp2 hybrid orbital. Likewise, you can have an sp hybridization where it's 1 s orbital paired with 1 p atomic orbital. Now we're going to go into this a little bit more and we're going to do some examples on our next video, but keep in mind whenever you're talking about, do some of the math to say, well, what is an sp hybrid orbital? That means you are taking an s orbital and a p orbital. And that's the whole thing. So what that means is it's 50%, it's a hybrid orbital that is 50% s and 50% p. Okay? Now if you had something that was sp2 hybridized, well then it's S plus P plus P. That means it's 33% approximately S, 67% approximately P. All right, well, I hope this is helpful. I think whenever you do some examples on this, it makes a little bit more sense. So bear with me, watch the next video.